In this problem, we need to solve this log equation. Log base 3 of the quantity 4x minus 7 equals 2. So in order to solve a log like this, where you have your variable inside the argument of your log, it's probably easiest to solve this if we change this into an exponential form of this equation. So we're going to change this from log to exponential. So if you recall, the base of our log is the same as the base of our exponent. So it's 3, and then we raise it to the second power, and it's going to equal the 4x minus 7. So 3 to the second equals 4x minus 7. And now we just have a pretty simple equation that we can solve. So evaluate 3 squared, that's 9. So 9 is equal to 4x minus 7. Add 7, we get that 16 is equal to 4x. Divide by 4, so we get that x is equal to 4. Now, if you recall back to when we talked about logarithms, we know that the argument and the base of a log must be positive. So before we can confirm that this is in fact the solution to this problem, we have to first make sure that this does make this positive. So we'll just do a quick check here, and we'll plug 4 back in. So we know 4 times 4 minus 7, that must be positive. So that's 16 minus 7, which is 9, and 9 is a positive number, so it works. So let's try this second problem. We want to solve this log equation where it's log base x of 64 equals 2. So just like we did in the last problem, because we have the variable in the base, we want to change it from from a log into an exponential form. So remember that the base of our log is the same as the base of our exponential expression. So we're going to take x and raise it to the second power and set that equal to 64. And then to solve this, we take the square root of both sides. And remember, anytime you introduce a square root into an equation, you get the positive and negative square root. So we get that x equals plus or minus 8. So we have two solutions here. But again, if you recall, when we talked about logarithms, we know that the base and the argument both have to be positive. And if we have the solutions of x equals negative 8 and x equals positive 8, if we plug negative 8 into this log, that's going to give us a negative value. So that means that this negative 8 is not allowed to be a solution. So our only real solution is this here, x equals 8. Because our base is not allowed to be a negative number. So let's look at one more example. So in this example, we're given an exponential equation to solve. Now, I don't really know how to make 5 and e something that we can express with the same base, because there's not really an easy way to do it. So in order to solve this exponential equation, we are actually going to have to use logs. So to do this, what we're going to do is we're going to change this exponential equation into a logarithmic form. So we have a log, and then the base of our log is the same as the base of our exponential. So it's log base e. The argument is what your exponential expression is equal to. And we know that this whole thing is just another way of writing the exponent. So it's all equal to 2x. We have another way that we can talk about log base e. We said in another video that log base e is also known as the natural log. So we can say this is ln of 5 equals 2x. Now the reason why we want to do this is because when we actually try and get the value of this, we're going to use the ln, the natural log button on our calculator. So then solve for x, so divide by 2, and we get that x is equal to the natural log of 5 divided by 2. Now this would be our exact answer, but if you want a little bit more context into what this number actually means, you could take this and plug it into your calculator. So if you took the natural log of 5 and then divided it by 2, you would get about 0.805 as your answer. And this is a perfectly acceptable answer because if you remember when we talked about exponential functions, their domain was all real numbers. So any value that I got for x would have been something that works in this exponential.